100 years ago, in 1918, the National Geological Survey was established to systematically map the geology of the Netherlands. Since then, mapping has continued uninterrupted. The Geological Survey of the Netherlands has now grown to be one of the most modern and advanced in the world. Take a journey with me to visit some of the most important events in this 100-year history and the time leading up to it. In 1833, long before the establishment of the Geological Survey, we meet Wynand Staring, a Dutch pioneer in the agricultural and subsurface sciences. His ambition is to map the geology of the Netherlands. On foot and on horseback, Staring travels through the country. With the help of a network of correspondents, he creates the very first geological map of the Netherlands. It is 1903, and the diligent search for new sources of extractable coal is underway. Visionary and scientist Willem van Waterschot van der Gracht is a much sought-after global expert in mineral, coal, oil and ore exploration. He discovers the Peelveld, with coal at an extractable depth. He advocates the establishment of a geological institute to strengthen and consolidate systematic geological research in the Netherlands. That geological service comes in 1918, when Cornelis Lely, Minister of Transport and Water Management, instructs Peter Tesch, the first director of the National Geological Society, to make a new geological map of the Netherlands. Together with a small team of 4 geologists, Tesch produces 184 map sheets, all at 1 in 50,000 scale. Let's jump now to the 1950s. The rapidly increasing demand for knowledge about the Dutch and North Sea subsurface justifies a new mapping program. For land mapping, we go deeper than ever before, to a few hundred meters below the surface. The North Sea floor can also be mapped with increasing accuracy, and a separate North Sea mapping program begins. Maps are still drawn by hand. The discovery of an enormous gas field in the northern Netherlands in 1959 arouses the interest of the oil and gas industry. The Dutch government can use the seismic data and borehole measurements the industry collects in its search for oil and gas to map the subsurface at great depths. In 1985, we begin mapping the deep subsurface at depths of up to 6 kilometers. In the year 2000, it becomes possible to develop 3-dimensional maps for various applications. 3D modeling is the modern development of the 2D mapping program, but does not replace it. One example is the 3D visualization of the uppermost 50 meters of the subsurface. Detailed 3D models give us better insight into the structure of the part of the subsurface we use most often. Models can be made of any area in the Netherlands. We can also use the increasing amount of data to give more detail to subsurface maps and application-specific 3D models. An example of this is ThermoGIS, which maps geothermal energy potential based on geological maps and subsurface properties. In the future, new IT developments will continue to play an important role in geology. Virtual reality will soon provide even more insight into uses for the subsurface. Drones and satellites will be deployed for imaging, and we will make more use of real-time monitoring. Artificial intelligence will also be able to help us better process and interpret geological and geophysical data. Technology will also make it possible to make models more reliable and more replicable. That means we will be able to assemble tailor-made maps online based on a specific research query. Thanks to this type of customization, we as a geological survey can offer insight into the future subsurface.